We'll start with 27. It's the only question on 27. Why is it negative? Okay. How many of you know why is it negative? Okay. Leah, tell us why is it negative?
Because with the equation that it gives,
Yeah.
it's an inequality.
Yeah.
So it has to follow that rule, and it says
Yeah.
that equals root cat has to be less than 0, and then anything that's less than 0 is a negative.
Yeah. Perfect. That answers everything. Okay. Move on. 29.
Oh, yeah, because
That's
it's
a 7.
Was that really enough?
Oh, yeah.
Good job, Leah. Okay. Instead of just negative, you shouldn't have been positive anyway. This whole time, it should at least be, so you switch x and y, right? So you have 16, 25 y squared. You have 25 over 16x equals to y squared. In your next step, you did this. And your mistake is that you didn't do that. Does that make sense? Now, kind of part of what your mistake is. Okay? Because when you have y squared equal to something, you have to add a plus minus. If you start out with y equals to root 2, or let's say root 4, this is just equal to 2. Because the radical sign only has the positive answer of the square roots. But if you start out with y squared equal to 4, then y has to equal to plus minus 2, because negative 2 squared is still 4. You understand the difference? I said this before. If you have y squared, you have to do plus minus. If you have radical 4, it's just 2. This is why when you have y squared, the radical, since only has the positive answer, you need to add the plus minus for the negative answer as well. Are we all good? Which gives us y equals to plus minus 5 and the 4 comes out, the x stays inside. Now, that tells you that the input has to be less than 0. And the inverse function is no longer called the input, it's now called the output. So y has to be less than or equal to 0. These two are saying the exact same thing. Does that make sense? Okay, when we do the inverse function, we're switching x and y, which means in the beginning when it says the domain is less than 0, equal to 0, now in the inverse function we're saying the output, the y, has to be less than or equal to 0, which means we can ignore the plus. Okay. Why does it have to do that? What's wrong with having plus minus? Huh? Why does it just not give it to you and make you do plus minus? It's not a function. Right? Again, I said this in the first week of school, Algebra 2 only care about function. They care about it so much that even when they give you a homework problem, they make sure that your end result stays a function. Does that make sense? Okay. When you have plus minus, radical graph looks like this. That will be the positive version. Negative radical will look like that. That makes it not a function. By saying that it has to be equal to or less than 0, then you force it to be just the bottom half. Okay? Good thing we do homework and answer questions on homework. I didn't teach that yesterday. Okay, I'm only helping Connie, not Jada, since Jada wasn't there. But you can listen too, to benefit while we do this. Remember, this is a reminder already. To check if a graph is a function, we're checking if every x has only one y. Every x has one y. Every x has one y. So we know that, for example, this would be plus minus plus 4 or something. Okay? For example, this graph would say x has, 2 y's. So not a function. Right? And this is called the vertical line test. You just have to draw a vertical line and see if there's any point on the graph there are more than 2 points. Vertical line test. That's how we test if a function is a function. Now, a relation is a function. However, when you have an inverse function, let's say the inverse of this over the 45-degree line give you that. So we have to test if that's a function. Is the red graph a function? No. Is there a way we can do that without looking at the red graph? Yes, because these red lines are same as these 4 blue lines. So we call it the horizontal line test, which is kind of dumb. But really, you're doing the vertical line test for the inverse using the original graph. That make sense? Okay. So let's go back to 29. 29, by looking at this, from what you know from chapter 2, that's first degree, which means a straight line. Straight lines are pretty much always a function unless it's a vertical line or horizontal line. Right? So that is a function. This one is a quadratic function. So you know it's not a function.
So whenever it's quadratic, it's not.
Okay?
Oh, so.
This one is a cube root. That is a function. This one is a quadratic, right? Intercept at -1 and +4. And horizontal line test, not a function. That one is a 4th root, so that means something like that. Not a function.
Yeah,
Even degree? No, it's opposite. Only if it's odd. Even are always u, right?
odd.
Now, even when it's odd, you can potentially have one that looks like this, which is not a function. But most likely, the ones I give you on the test will be easy to visualize. Or I would just give you a graph. I would just give you that graph and say it's an inverse of function. And you would know it's not because of 3 points. Yes, Morgan.
So how do you tell if it goes like that?
What? Chapter 2.
Is it just
Chapter 2. Remember what chapter 2 was? Polynomial functions?
Yeah.
The shape of the graph depends on the degree.
Yeah, no, I know how it goes like that, but how do you know if it bounces back and it's not?
You mean for a third root
Yeah, or odd.
or odd root? You just have to graph it. However, like on this homework, none of it require you to graph. Oh, wrong place. Never mind. Down here. None of these require you to graph. Because that one is just a parent function. You know parent function doesn't go back. That's why on the homework they don't bother graphing. But if it's something more complicated, then yes, you will have to actually. Unless it's square, then you don't need to. You know it's not. Does that make sense? Okay. If it's odd degree, you have to actually graph it to know for sure. Unless it's this one. Oh, this is like the messiest. Unless it's this one. What? Unless that one, because it's parent function. You know parent function doesn't loop back. And then there's one more, right? 41 and 49. 41 and 49. Next page. Oh, no, it's right here. Find the inverse of the function. 41. Is the same question? Is it about the negative, or is it actually doing the problem? Who needs help on 41? Is it the negative, or is it other things?
Why is the inside 40 minus 5x?
What is inside 40 minus 5x?
I got 5x minus 5.
Why don't you move the 2 to the top?
Okay, let's try it. So I have x is equal to. Yeah, why don't they move the x to the top? I don't know. They say back grammar. They want you to do it and they don't want you to do it. So x minus 8 is equals to negative 2 over 5y is 6. Oh, I see. Why don't they do... Oh no, it is right. So when you multiply this in, you multiply this by 5 over 2. That cancels out. That's negative 5 over 2x plus 40 over 2 equals to y to the 6. Which means this is 40 minus 5x over 2 equals to y to the 6. I think you're only getting confused because you think that this negative is that negative. It's not. This negative is that negative. Does that make sense now?
Yeah.
Okay? So you take the 6th root, which had to be plus minus. 6th root plus minus. So end up with y is equal to 6th root of 40 minus 5x over 2 plus minus. But since the original says x had to be greater than, let's do 0, that's just a minus. And the proper answer is going to multiply by 32 negative e building minus e building x 6 root. This is a proper answer. Yeah, it just has that.
Why is it times 6?
Because you shouldn't really have radicals on the bottom.
Times it by 5.
5 2's, which is 32. So you multiply top and bottom by 32 inside the radical, you get something back. Really, you should just do this. Remember when we were doing this, it was kind of confusing when you're like, well, do you have to do it on the test? Are you going to mark it wrong? And I was kind of vague about it. Because the book itself is kind of vague about it. But really, you should always go for this one. There's no question that is right. If I really want to take the point off of like that, I could, and then you can take the book and say, the book gave me this, and I have to like decide. You know what I mean? If you do this, it will always be right. Okay, one more. 49. I think that's down on the next page. Is it? Yeah? Is that 49? Okay, this is the one that we rushed quickly during class. But basically, you're finding an inverse of the model. You don't even really need to read the question. But again, this is a physics formula, which means it's natural law, which means the inverse would be just as true as the original formula. So we don't switch a variable again, because it's not like the speed, velocity, suddenly turn into the length, right? Just that instead of input being length, and you give the speed, you turn it around, you want to give the speed as input, and you want length as output. So we're simply solving for L by first dividing both sides by 1.34 equals to radical L, and then you square both sides. You got L is equal to V squared. I'll just use a calculator. So 1 divided by 1.34, and then squared. So multiply, enter. So 0.55. 0.56. Does that answer your question? Did you guys know that you can do that on the calculator? If you're doing 1.34, did I already click the calculator? You do 1, let me clear this first. 1 divided by 1 divided by 1.34, which gives you 0.7. You want to multiply by itself, you can just do multiply, and that number is already on there, just by equals. Multiply by the number. Okay. You pretty much does that on every possible calculator. So. Okay. Any follow-up questions? Anything you're still not sure of? Basically, again, at this point is when we'll do the quiz, which means you might find out something you don't understand from the quiz. But you should be able to, if I ask you to do a thumb up, sideways, or down, you should all be up right now. Are we all up right now on 3.4? Okay. What's still kind of confusing? We can do another example together.
Determine whether it's a function or not.
Okay, function, non-function. We can look at that one more time. How about you?
Same.
Same? Andrew, what do we have?
But I should be good.
Okay, let's look at the even questions that we didn't do in this section. Okay, so let's look at, why is this getting so confused? Let's look at something here. And usually in life, you won't have the answer right there, so let's go ahead and block it. Ooh, there's some good ones in here. So let's go ahead and look at all of these right now. Okay. When you're not sure, you can always graph. For example, number 30. In my head, I can already see -5, I missed it, but you get the point. So we have -5 as a y-intercept, -x as a -1 as a slope. Does that make sense so far? Inverse is or is not a function? Is, because there's no output that has one input, more than one input. Because the inverse of this graph would actually be the same graph. Okay? Which means for number 30, f of x equals -x minus 5. The inverse is actually itself, -x minus 5. Okay, are you good with this one? Okay, 32, you see a, in your head, you see that. You all see that from chapter 2? However, it tells you that x has to be negative, which means we ignore, positive, sorry. Same difference. We ignore the negative part. Okay? Now that's what we see. And then we do the horizontal line test. Is the inverse a function? Yes. Okay? And this is why they introduced this, so that our inverse will be still a function. Number 34, we have the parent function -2, which means we shift it down to still looks like a parent function. The inverse is a function, right? 36 is interesting. Okay, think about it. Talk to your shoulder partner. Tell them why you think it is or is not a function for the inverse. It's the x that has to be positive. This is limiting the x. My domain is only positive. This is x. This way. This is y. It's limiting the x. It's not limiting the y. Make sense? Hey, who can tell us why 36 is or is not a function for the inverse? But go ahead.
If you're putting positive and negative 1, then the outcome will always be 7.
Right. What does the graph of the absolute value look like? A V shape, right? This is the parent function. So this is the actual function. And this would not pass a horizontal line test. It also means that the inverse graph will actually look like this. And the vertical line graph of the inverse looks just like the blue line. So it's not a function. Okay? And notice I dropped this green line by flipping it over the 45-degree line.
Doesn't it only have one answer if you put a number into x?
Yeah, because the original function is a function.
The inverse.
But the inverse is not. This is a function. This is a function. This is a function.
How is that first one a function?
This is not a function.
It crosses the lines.
Which one?
It crosses multiple lines. The graph of the original function.
The V?
Yeah.
It doesn't.
Oh, you do. Oh.
Remember, the vertical line test is what actually tests the function. The horizontal line test is doing a vertical line test on the inverse. That's why it's kind of confusing. I think that name is kind of lame. They should just make you visualize the inverse and still do the vertical line test. I think the idea of having a horizontal line test is kind of dumb. Does that make sense? When you do these blue lines, what you're really doing is doing the green vertical line test on the inverse. It's just that instead of thinking about this one, you might as well just think about the blue. Okay? Any other questions before we move on? Okay.